Alright, this is the third video for Chapter 4, Section 1. We're going to be looking at finding more missing sides of triangles, their angles and their side measurements, using sine, cosine, tangent, inverse functions, and also the Pythagorean theorem. The last two problems of this video here, for our 5 total problems, the last 2 are going to be story problems. So let's have some fun with that. Now, like before in the previous video, I'm going to make a triangle that mimics the one on the right. This time we know that the hypotenuse is 10, and we know that angle A is 40 degrees. So what we're going to find is the measurement of angle B and side length B and side length A. And again, like in the previous problems from the previous video, the easiest thing to find is the missing angle. So B is 50 degrees, because 50 degrees, 40 degrees, and 90 degrees equals 180. We're going to find measurement of side A. And to do so, we're going to use a relationship between 40 degrees, A, and 10. And so that would be the sine, because sine is opposite over hypotenuse. Now the sine of 40 degrees is equal to A over 10. And what I'm going to do is multiply both sides by 10. So 10 is equal to just A by itself. Or 10 sine of 40 degrees is equal to A by itself. So A is equal to 10 times the sine of 40 degrees, which is going to be approximately 6.43. And since I know that A is now 6.43, I'm going to use the Pythagorean theorem to find B. Now, you'll note that in the last several problems, we've had a squared plus b squared equals c squared to find my missing side C. But in this case, we actually know side C. So we actually know C and we know A. So we're actually going to find the missing angle B. So one of the another ways to write this is c squared minus a squared is equal to b squared. Or our hypotenuse squared minus one of the side lengths is going to be equal to the other missing side after you take the square root. So 10 squared minus 6.43 quantity squared, 10 squared minus 6.43 squared is equal to a number, once you take the square root of it, that B is approximately 7.66. Now, what I'd like to do at this moment is bring up something called the hinge theorem. The hinge theorem says that the proportion, it's kind of hard to say not proportion, but the sizes should correlate between their angles that are across from them. And to put this in perspective, the 40 degree angle is across from the shortest side. The 50 degree angle is across from the medium size side, which is 7.66. And the biggest angle, which is 90 degrees, is across from the biggest side, which is the hypotenuse. So it's a good way to kind of check your answer to make sure you didn't make a mistake. When you get your final answer, make sure that that relationship holds true. It might save you some points on the test. Okay, for the second problem of 5, here we know that the side A is equal to 2, side B is equal to 8, and we want to find side C and the angles that go along with this picture. Now, this doesn't actually have a very easy first step because in this case we know none of the angles. So our best bet is to either find a missing side or to find a missing angle. So let's find the missing side first, because Pythagorean theorem will lead the way. 2 squared plus 8 squared equals c squared. You add these up and then add these squares up, and then you take the square root of that sum. So c is going to be approximately 8.25. So c is the largest side, which makes sense because it's across from the 90 degree angle. But now what we have to do is we have to find either A or B, and let's find A, why not, right? And I think I want to stick with the numbers that I'm given here. So the relationship between 2 and 8 from A's perspective would be tangent. So the tangent of A is equal to 2 over 8, or the tangent of A is equal to 1/4. Now to solve for A, we have to use our friend the inverse function, because we had back in chapter 3, we learned that inverses are basically written as this. We flip-flop the 1/4 and the A in their place, and I'll show that to you here, that now I have the inverse tangent of 1/4 instead of A being in its place. Now the 1/4 in its place is equal to A. So A is equal to the inverse tangent of 0.25. On your calculator, that would get an approximate answer of 14.04 degrees. It's important to write your answer with degrees because that's what we're talking about. Now, since angle A has a measurement of 14.04 degrees, then measure of B would, or B's angle, I guess I shouldn't put the degree symbol there, B's angle is going to be from 180 degrees, the 90 and the 14.04, so we get an answer of approximately 75.96 degrees, which makes sense. I mean, B was a pretty big side. I mean, B was 8, and therefore that angle had to be pretty close to the 90-degree angle that the 8.25 was. And A was really small, so it has to be a pretty small angle. So if I drew this to scale, it would be a very slender triangle like so. And so this would be 14 degrees. This here would be 75 degrees, or 76 rounded correctly, and then this would be 90. All right, so for our final example here, we're going to have our known side 6, we have our known side 4, and we have our missing side A. We know none of the angles, so here's angle A missing, here's angle B missing. So let's use Pythagorean theorem to find side A. So 6 squared minus 4 squared is equal to A squared. You can see that essentially I'm adding the two sides if I don't know the hypotenuse, and I'm subtracting the hypotenuse and the smaller side if I don't know the other side as well. So 6 squared minus 4 squared, and then when you get your answer, you take the square root of that. You get an answer of approximately, A is approximately 4.47. So that's done by, again, taking 36 minus 16, then take the square root of 20, which is about 4.47. Now what we're going to do is find angle A, and we're going to find angle A from this perspective, which is going to be the adjacent over hypotenuse. So angle A is going to be, let's go with our cosine of A is equal to 4/6. Now we take our inverse here. The inverse of 4/6 is equal to A, and then you can decide to simplify this or not. You're typing this in on a calculator, so typing in the cosine of 2/3, inverse cosine of 2/3 is the same as the inverse cosine of 4/6. So what you get here is you get that angle A is 48.19 approximately. Angle A, 48.19 degrees. And we subtract from 180 degrees to get angle B here, so that's going to be roughly 41.81 degrees. All right, let's go take a look at the story problems to round out this video here. We've got some applications. Okay, so it says here, the hypotenuse is 5 feet and a leg is 4 feet. Okay, so this pretty much is a straight up problem dealing with no context, just giving you the definitions here. So it says find the measure of each angle. Now it is not required to find this missing side, which it would be 3, but we're going to call this, again keeping all things the same, we're going to call this angle B, we're going to call this angle A. So let's find angle A first. So from the perspective of angle A, this is opposite over hypotenuse, so this would be the sine of the opposite over the opposite over hypotenuse here. So this is going to be, let's see here, sine of A is equal to 4/5. All right, sine of A is equal to 4/5. So what we're going to do is take the inverse sine of this. So the inverse sine of 4/5 is equal to A. So our A in this case is going to be 53.13 degrees. Now, to find angle B here, what we're going to do is we're going to take the cosine of B is equal to 4/5. Cosine of B equals 4/5. So again, take the inverse of this cosine, which swaps this and this. And therefore, if I type this into the calculator, this gives me 36.87 degrees equals B. Now, I think some of you might have said at the moment where I got to this moment, could I have subtracted that from 180 degrees and got my 36.87? And your answer is yes. Subtracting the 53.13 and the 90 from the 180 gives you the 36.87, but it's probably good to check, right? It's probably good to check just to see if things are going well. Plus, this is also an application of this idea. If I have the sine of 25 degrees, that's equal to the cosine of what degree measurement? What degree measurement is this equal to? The sine of 25 degrees is equal to the cosine of what degrees? Let me think here. Well, if this is the complement of 90 degrees right here, this would take us to 65. Because 25 and 65 add up to 90, so you can see that these are also complements of each other. That's 53.13 and 36.87 add up to 90 degrees right there. Alright, so our final problem here, if the hypotenuse is 10 feet and one angle is 30, find the length of each leg. Okay, so the hypotenuse is 10 feet and one angle is 30. Now it doesn't mention which angle is 30 degrees, so we can make that whatever we want. So let's take this as 30. And let's assume you don't remember your special triangles from your geometry days, so let's just call that A and B. Now, what I'm going to do is solve, let's say I'm going to solve A first. So I'm going to use my cosine of 30 degrees is equal to A over 10. So what I will do is just multiply everything by 10. And if I multiply everything by 10, I get 10 cosine of 30 degrees is equal to A. So A is approximately 8.66. Now, what I'm going to do to find B is I'm going to use my Pythagorean theorem. 10 squared minus 8.66 squared is equal to B squared. Now, if I subtract these two, I get a number that's pretty close, and if rounded correctly, gives me to 25 equals B squared. You're going to find out that B is equal to 5. This, my friends, what I've just done is the 30, 60, 90 triangle. And though you may not have remembered that from high school, the 30, 60, 90 triangle has a pretty interesting property. So it is 2x, x, and x square root of 3. So from the shortest side of the triangle, I can figure out the other two. Like for example, if I know that the shortest side is 5, I know the biggest, or the hypotenuse side, is 10. That means the longer leg is 5 square roots of 3, and if you approximate it, 5 square roots of 3 is 8.66. These special triangles are really important depending on your field of math, so it's all different depending on where you go and what you need, but this actually wraps up the two-story problems we have for today, so thank you for watching, and I appreciate the time you spent learning some trigonometry with me.